establishing the best regression model. By the end of this video, you should be able to determine which of several models does a better job of describing the relationship between two quantitative variables. So for this, I collected data for you using these pullback cars. So unfortunately, you guys weren't in class for this. It was fun. So we had our little pullback cars, and I would pull them back from the start 2 inches, 4 inches, 6 inches, and 8 inches. And then I would see how far they could go when I let go of them. All right, so I collected data. Let me give you the data so you can copy it down. So here is your data. Go ahead and pause the video to get this data off onto your paper. All right, now that you've gotten the data, what we're going to do is we're going to create a scatter plot for each. We're going to calculate a least square regression line, and then we're going to analyze linearity. And so the ways we know how to do that is we want to look at residual plot, and also go ahead and find your correlation coefficient and your standard deviation. We're not going to use the standard deviation of the residuals because we're not going to calculate that, and I don't want to use the applet because you can't use the applet on the AP exam. So we're just going to look at regular standard deviation here. So in this area, we've got a bunch of things that we've got to do. We're going to make a scatter plot. I'm going to show you how to have your calculator make this for you. Okay. And we're going to calculate the least square regression line, and we're going to put our residual plot and note what our correlation and our standard deviation are. So you're going to need your calculator, and you're going to need to put in your calculator your explanatory variable is your pullback distance. So it's going to go in list 1. Your distance traveled is your response, because it's the response to how far back it was pulled back. So that's going to go in list 2. Pause the video and come back when you're done. Alright, so we've got your data into our calculator. Let's see what we've got. I always calculate the equation of the line first. That way I know the calculator knows what I'm talking about. So remember to get your regression line. Stat, calc, choose number 8. Make sure this says list 1 and list 2 because this is where we have our x and y's right now. And calculate it. So I have a y hat equals negative 13 plus 17.58x. Now let's put this into context. So we're predicting a distance traveled. And we're going to get the same equation. And the x is how far you pulled back. So now it's in context. All right, now let's see the scatter plot of it. You could just go ahead and graph it. Your scatter plot's going to look a little different because I collected data on the same values more than once, so the dots are going to stack up with each other. So we've calculated our line. So stat plot is right here and above y equals, so second y equals. Make sure the other plots are off, and make sure you actually have nothing in the y equals because that kind of messes everything up. So we're in second y equals. Make sure you've highlighted on. You want to choose this first kind of graph. That's a scatter plot. This is a line graph. We have a histogram. We have 2 kinds of box and whisker plots, and that's your normal probability plot. Your data is in list 1 and list 2. So I have the residuals here, and I'm going to show you how to do that in a minute. But I need to change it to list 2, so that's where it's getting its information from. And then hit graph. I don't see anything, so you have to zoom to where it is. So you hit zoom and number 9, and it takes you to your scatter plot. And you're gonna, don't worry about labeling all the axes and everything, just let's do a rough sketch of this and restart the video when you're done. All right, so if you look at this, there's not always 3 dots, and what's happened is because of our Y scale, you have, and the numbers are so close together, so we have 25, 32, and 23. 25 and 23 are very close together, so that's actually 2 boxes super close together, and then the 32. These 3 numbers were all very similar. You had 54, 54, and 53. So on the scale that we're on right now, you can't really tell, but it is still 3 separate numbers. right, so we have our scatter plot. We've sketched it, and we want to see how linear this is. So let's make a residual plot. Now you don't have to do this by hand, the calculator does it for you. So go back into your stat plots, which is second y equals. Go into the one we're in. You're going to take your x values from list 1 still, but instead of going to list 2 for the y values, we want the residuals, because that's how you graph a residual plot. So the calculator will calculate them for you without doing any of the extra work if you put residual here. So right here above the stat button, it says list. So second stat, and it puts all the lists here. But the very last one is residual. So if you choose number 9, it'll pop residual in there, press graph. Now you still always want to zoom to make sure you're getting your best view. Alright, so here's our residual graph. Pause the video and go ahead and make a quick sketch of this on your paper. Alright, so I don't know if that's scattered or not. Let's go ahead and you're going to do these other 2 models to see if there's a difference. Let's go and get our correlation and our standard deviation, and that might help us make some decisions too, because a residual plot is just one part of this. So we want our correlation and our standard deviation. So correlation, remember, is in your regression line. So your correlation here is 0.985. And for our standard deviation, we're not going to do the standard deviation of the residuals because that's not easily calculable on your calculator. So we're just going to look at regular standard deviation. So stat, calc, we're talking about 2 columns. That means you're wanting to look at 2 variable stats. List 1 and list 2 is where everything's at. And you want the sample standard deviation, SX, okay, 2.34. So right now that doesn't necessarily mean a lot. We'll have to see what the other graphs look like and what their standard deviations are. So what I want you to do is I want you to pause the video and I want you to do these 2 on your own. So let me give you a hint here that's going to save you a little bit of work. Let's work smarter, not harder. This says what you need to do is square the x's and leave the y's alone. So let's go in to look at our lists. Instead of changing all these numbers, let's go over to list 3 and tell it take list 1 and square it. And it will do this for you. So now when you go to calculate your line, you're taking your information. Instead of list 1 and 2, you're going to use list 3 for your x's and list 2 for your y's. Okay? And then do the same thing down here. Your x's are already in list 1, just leave them there. Your y's, you can just reprogram list 3 to take the log of your y column. And so do your scatter plot, your equation, your residual plot. You'll want to get your correlation and your standard deviation, and then make a decision of what you think is the best residual plot and why. You can have different reasonings, okay? All right, come back when you're all done. Okay, so here we go. You should have something pretty similar to this since we're using the same numbers. And I agree that you're probably thinking it's kind of hard to tell with our scatter plots which one's best has the most scatter because we've stacked up the data, so it does make it a little bit harder to see. So let's go and look at our correlation coefficients and our standard deviations. And what I notice is one right off the bat is significantly different. Even though the correlation coefficient is even stronger, look at the standard deviation. That's a lot of error that we're looking at, a lot of average distance from the regression line. So that is not what we want. So I would say if you chose either linear or exponential, you can make a case for either one of those at this point. Okay, so what I want you to do is I want you to calculate for number 2, how many inches will you have to pull back for the finish line if the finish line is in 100 inches. Now think about this before you go too far. 100 inches is where you're finishing. So what variable is that? Pause the video, come back when you're done. Alright, so I have each of our models here and I solved for the pullback distance. And we were saying that standard deviation on the quadratic was really big. Look at the quadratic pullback distance, 44.5 inches. I'm pretty sure you would have broken the toy if you pulled it back that far. So that's another good idea that was maybe not our model that we should use. Using the linear, you should have gotten 6.43 inches. And we didn't have to undo anything because we didn't do anything. It was straight up what we started with. Now we had our exponential one over here where it said take the log of y. So remember, because we did something with y, you have to undo it. So you undo that by raising to the 10 to both sides. And I got 6.5 inch pullback. Those are pretty similar. And so really here it's kind of hard to say which one was better than the other because there wasn't a real definitive answer there, but either of those are good choices. All right, go ahead and flip this over. I have just one thing to tell you. It's going to take the whole box though. So we're going to talk about choosing the best regression model. So this is more like what's going to happen when we do our check our understanding in just a minute. You're more than likely going to be given some scenarios and you're checking it over. You're not going to be, you wouldn't have to collect the data for sure, but you would not be generating, I think it has to be this one all on your own. They're likely to give you choices like we did on the front, and you apply those choices to the data and see what happens to it. Okay, so the first thing, you're going to want to check the scatter plot for a linear pattern. So the first thing you want to do is check your scatter plot for a linear pattern. On the front of our paper, our data looked pretty linear, but you never can tell for sure until you start looking at residuals and other things. Okay, then the second thing you should look at, check the residual plot for no leftover pattern. Remember, if there's a pattern, it's not linear. Okay, and your whole goal to move forward to make a least square regression line is you need it to be linear, otherwise it's not appropriate. And the final thing, if you're deciding between several models, I should say models, not modes, R and S, your correlation and your standard deviation, can be used to decide which is best of all the models. Okay, so there's more than one piece of data that you can look at. Once you've finished writing, go ahead and answer the questions, the 2 questions for check your understanding, and I will put the answers up. All right, so this is much more likely how a question could be asked for you. So we have 3 models, and so we have a linear model. The letters down here correspond with what's going on up here. Linear model is just x versus y, nothing's changed. We had a power model, and you can see how it says it's the natural log and the natural log on both of them. So both of them had a logarithm applied to them. That's what makes it the power model. And then on our third model, we have just age and then the natural log of the premium. So it was only applied to the y. That makes it an exponential model. Okay, so when you calculate each of these out, here's your numbers you should have gotten. If you did something to the y value, as you did in power and exponential, remember you have to undo it. So let me show you. So if you got to the 4.95, you're halfway there because remember it's the natural log of the premium. So if you have a natural log, you undo this using the E. That's Euler's number, and it's a constant that's used, and it's the opposite of a natural log. So the E here cancels the natural log, leaving just the word premium. And then over here, you have the E button on your calculator because it's the opposite of a natural log. Here's your natural log. It's the opposite of it. So we're going to hit second natural log, and it's going to give us the E and with our exponent, and then you just put 4.95 in it. And that will give you the 141.17. Okay, same thing here. We had the natural log in front of the premium, so you had to cancel that word out. So if you undo it on the left, you've got to do it the same thing on the right. So I came up with a premium of 137 predicted over here. Of these, which one was the best? Well, when you're looking, you can see that there's a pattern in our residuals here. There's a pattern in our residuals here, but in this one, that is scattered. So that's what made this one the best choice for the exponential. So don't just say exponential, you need to explain your answer. So it's exponential because the residual plot shows no leftover pattern. Hopefully that makes sense. Let me know if you have any questions, and I'll see you in class.
Yeah.